Hello students, in this video we'll show there's a relationship between the Schwarzian derivative of a function and the Schwarzian derivative of a composition of a linear fractional transformation with that function. So in particular what I mean given constants a, b, c, and d with ad minus bc not equal to 0, which is a common assumption for linear fractional transformations, we have that the Schwarzian derivative of as plus b over cs plus d, that's the Schwarzian derivative, is the same as the Schwarzian derivative of the function, okay? Let's remember what these Schwarzian derivatives are from a previous video. We know this is exactly equal to s triple prime over s prime minus 3/2 s double prime over s quantity squared. And algebraically, I can show this is equivalent to s double prime over s prime prime minus 1/2 s prime prime over s prime squared. So you can check that using the quotient rule. It's easy to see. And so I'm going to use this sort of formulation of the Schwarzian derivative to prove my result. So let's do it. So let's call this function over here, I'm going to call that function over here just plain old f. And so let's do the derivative of f. And so if that's f, I know that f prime is going to be what? It's going to be the bottom times the derivative of the top, as prime, minus the top, as plus b, times the derivative of the bottom, which is going to be a cs prime, all divided by cs plus d quantity squared. Now notice that when I do this, I have a cs times as prime and an as times cs prime with a negative. So those terms are going to cancel out over there. And so we're just left with ad minus bc times s prime. So this is going to be equal to ad minus bc s prime over cs plus d quantity squared. Beautiful. Now what I'll do is for notational convenience, I'm going to call this thing over here delta. So what this is equal to is this is equal to delta s prime over cs plus d quantity squared. Excellent. Let's do the second derivative of f now. What's the second derivative of f going to be? F double prime is going to be, well, it's going to be a delta s double prime over cs plus d quantity squared, that's doing the derivative of this first function, plus delta s prime, and then I'll have a cs plus d to the third power, and then this is like really like a negative 2, so I'm going to have a negative 2, then I have a negative 2, a c, and then an s prime, okay? So what this simplifies to is this simplifies just to, there's a delta in front of everything, and then we'll have a s double prime over cs plus d squared, and then we'll have a negative 2 c s prime squared over cs plus d quantity cubed. Excellent. So now of importance to us is to look at the ratio of these things. So what's the ratio of f and f prime? So if I look at the ratio f double prime over f prime, what are we going to get? So I really have this expression over here divided by this expression. So let's figure out what's going to cancel out. So clearly this delta is going to cancel out between both terms over here. So this first term over here, I'm going to have a cs plus d squared, cs plus d squared. That will cancel the first term. So the first term when you do the quotient is just going to be a what? It's just going to be an s double prime over s prime. Beautiful. And then the second term over here, what will cancel out? So I'm going to have a negative 2, and then I'm going to have a quantity of what? So one of these s primes is going to cancel out, and then one of those factors is going to cancel out. So let's carefully do that over here. So notice that we're going to have a negative 2c, so negative 2c, that stays on top. This s prime squared over s prime is going to give me one s prime, so that's going to be an s prime. And then I'm going to have 3 of these things in the denominator over here, and then 2 of those things are going to be flipped up in the numerator, so I'm going to have one of those things in the denominator. So I'm going to have one thing in the denominator, which is going to be a cs plus d in the denominator over here. Great. All right, so now I need to take the derivative of this thing, so let's do so. So what's the derivative of this thing? F double prime over f prime prime. That's the first thing I'm going to need to check, right? it's going to be s double prime over s prime prime, just the first thing. And then minus, let's do the derivative of this thing. It's going to be the bottom times the derivative of the top. Bottom times the derivative of the top. Minus the top, 2cs prime, times the derivative of the bottom, which is going to be a cs prime. All divided by the bottom squared. That's by the quotient rule. Excellent. Now, we're in good shape so far because I know that the first term of my Schwarzian derivative of f is going to be this term over here, and that exactly matches with this first term of the Schwarzian derivative of the function. So that's good news for us, right? So this term completely matches. This term over here matches this term over here. Beautiful. And now I have to compare 1/2 f double prime over f quantity squared. So I'm going to square this term over here. And what we get if we square this term? Well, I'm going to have a negative 1/2. This term squared, right? The first term squared, s double prime over s prime squared. Beautiful. That's exactly what I need. That's the term I need. And then I'm going to have this times 2, right? So that's going to be a total factor of what? So we're going to have a factor of a what over here? Then we're going to have a factor of, so this times 2, so let's do it slowly. So if I do this times this, these two factors multiplied, I'm going to have a minus 2. And then we're going to have an s double, let's just do it slowly, s double prime over s prime times negative 2c s prime over cs plus d. Okay, that's the cross terms. And finally, I'm going to get what terms over here? I'm going to get those terms over there squared. So I'm going to have a 4ac squared and s prime squared over cs plus d quantity squared. Okay. So these are the terms that are good. So let's highlight the good terms over here. So the terms that agree with the Schwarzian derivative of the original function are what two terms? So this term over here and this term over here, when I do the subtraction of f double prime over f prime prime minus 1/2 f double prime over f prime squared, those two terms agree with the regular Schwarzian derivative. And I'll look at the last couple terms over here. So if I have this minus 1/2 2, I have this term over here. This term over here is exactly what? Is exactly the same as what I get when I look at one of those terms that can cancel out, is exactly the same as this term over here. So those terms are completely the same. And then these terms over here are exactly the same as well, because I have the factor of 1/2, which will cancel that out over there. So I get exactly the same sign, exactly the same parity. So in fact, we see that these two terms agree with each other. So when I take this term over here, f double prime over f prime, and subtract 1/2 f double prime over f prime squared, all that will remain is this term over here and this term over here. So that shows that the Schwarzian derivative of a linear fractional transformation is the Schwarzian derivative of f. Now the cool thing about this is that since I know the Schwarzian derivative of x is just 0, that's trivial to see, that shows us that the linear fractional transformation satisfies the Schwarzian derivative condition that it vanishes. Namely, if I have ax plus b over cx plus d, the Schwarzian derivative of this thing is equal to 0. And so that is a differential equation satisfied by every linear fractional transformation. Thank you very much.